Today we're going to explore a scientific discovery that completely changed the way we understand sleep, and what it actually does to your brain while you're sleeping. Every night, while you sleep, something happens inside your brain that science took centuries to discover. It's not dreaming. It's not rest. It's a biological process so precise, so sophisticated, that the world's greatest neuroscientists were stunned when they finally found it. And the most disturbing part? It begins to fail silently long before you ever notice. For decades, a simple question puzzled scientists: how does the brain get rid of its own waste? The rest of the body has a system for that. The lymphatic system runs through every tissue, every organ, collecting metabolic waste and disposing of it. It's a cleaning network that works continuously, keeping the body's internal environment healthy. But the brain is isolated, protected by a nearly impenetrable barrier that controls everything that enters and everything that leaves. And for a long time, scientists simply didn't know how the waste produced by neuronal activity was being removed. That mystery remained open for over 100 years. Until 2012. That was the year a researcher named Maiken Nedergaard, at the University of Rochester, made a discovery that forever changed how science understands the sleeping brain. She and her team identified something that had never been described before. An entire cleaning system, specific to the brain, that had remained invisible to science until that moment. They called it the glymphatic system. The name comes from a combination: the glial cells, which form the brain's support structure, and the lymphatic system, whose function it mirrors. It is, essentially, the brain's sewage system. A network of microscopic channels that uses cerebrospinal fluid to wash through brain tissue, collecting toxic proteins and waste products that accumulate throughout the day. And then came the part that truly caught the attention of the scientific world. This system operates almost exclusively during sleep. In 2013, Nedergaard's team published a study in the journal Science that revealed the mechanism with striking precision. During sleep, brain cells shrink. Literally. The space between them expands by up to 60%. And it's precisely in that expanded space that cerebrospinal fluid flows far more efficiently, sweeping away the waste that built up during waking hours. Among that waste, two substances became the focus of a much deeper investigation: the protein beta-amyloid and the protein tau. You've probably heard those names before. Because those are exactly the proteins that accumulate in the brains of people with Alzheimer's disease. Think about what that means for a moment. During the day, your brain works. Neurons fire. Connections form. Mental activity inevitably produces waste. And among that waste are protein fragments that, if allowed to accumulate over time, can become something very dangerous. At night, while you sleep, the glymphatic system goes to work. The channels open. The fluid flows. And the brain, quite literally, cleans itself. This is the brain's night shift. But what happens when that shift doesn't go as it should? In 2020, Nedergaard herself published a new paper, again in the journal Science, alongside researcher Stephen Goldman. The title was straightforward: Glymphatic Failure as a Final Common Pathway to Dementia. The central idea was provocative. Different neurodegenerative diseases, with different causes, different symptoms, Alzheimer's, Parkinson's, other forms of dementia, might share something in common. A failure in the same system. The system that cleans the brain during sleep. And here is the detail that makes all of this urgent for anyone in their 40s, 50s, or 60s. The glymphatic system ages. And as it ages, deep sleep changes too. Research on sleep architecture shows something consistent: starting in middle age, the amount of deep sleep a person experiences begins to decline progressively. Deep sleep, technically called slow-wave sleep or stage N3, is precisely the stage in which the glymphatic system operates at its highest efficiency. Less deep sleep means less cleaning. And less cleaning, over years and decades, can mean accumulation. We're not talking about one bad night of sleep. We're talking about a pattern that sets in gradually, almost unnoticed, during the most important years of adult life. Here comes the question that many researchers are now trying to answer: is this relationship merely an association, or is there an actual chain of cause and effect? The answer is not yet definitive. Science works with honesty. But the evidence accumulated over the past 2 decades points in an increasingly clear direction. Neuroimaging studies have begun directly measuring glymphatic activity in living humans, using a technique called DTALPS, which evaluates fluid flow along the brain's perivascular spaces. The results show that older adults with compromised sleep quality display lower glymphatic activity scores. And lower scores are associated with worse cognitive performance. In 2024, a study published in Molecular Psychiatry, a journal from the Nature Group, analyzed 72 older adults using simultaneous MRI and sleep monitoring. The conclusion was direct: poorer sleep quality was negatively correlated with glymphatic function. And reduced glymphatic function was associated with memory decline. This is not coincidence. It's biology. But there's something even more fascinating in this story. And it's something most people never consider. The glymphatic system is not simply a passive waste collector. It also transports essential substances into the brain, including lipids, growth factors, and neurotransmitters. When it underperforms, it's not just the garbage that gets left behind. It's also the supply that never arrives. Think of it like a city where the garbage trucks stopped running at the same time as the delivery trucks. The result, over time, is not just an accumulation of waste. It's also deprivation. And chronic deprivation of essential substances can contribute to inflammation, to the deterioration of neural connections, to that feeling so common in older adults that the brain simply doesn't work the way it once did. In 2025, researchers at the University of Rochester published new findings on the mechanism by which the glymphatic system is regulated during sleep. The study revealed that brain neuromodulators, substances like norepinephrine, serotonin, and dopamine, which remain active and irregular during wakefulness, synchronize into slow, repeating oscillations during non-REM sleep. It is precisely those oscillations that generate rhythmic changes in blood vessel size, creating a pumping effect that drives cerebrospinal fluid through brain tissue. In other words, deep sleep is not merely the setting in which the cleaning happens. It is the mechanism that makes the cleaning possible. Without those slow waves, without that precise rhythm, the system loses efficiency. And the brain wakes up slightly dirtier than it should. Night after night. Year after year. There is an image that stays with you after learning all of this. Think of your brain as a city that never stops. During the day, the streets are full. Traffic is heavy. Activity is constant. And inevitably, waste accumulates. At night, when the city sleeps, the most important shift begins. The cleaning crews come out. The streets are washed. The channels are cleared. The city wakes up renewed, ready for another day. Now imagine that, slowly, those crews begin working fewer hours. Or with less efficiency. The streets don't become completely dirty overnight. But over months, over years, the buildup gradually becomes visible. And then, inevitable. That is the story science is telling about sleep and the aging brain. This is not a story of fear. It's a story of understanding. Because understanding how something works is the first step toward truly valuing it. And perhaps sleep is, among all the things we do every day, the one that most needs that recognition. For a long time, sleeping well was treated as a luxury. As a sign of laziness. As wasted time. Modern culture glorified sleep deprivation as a symbol of productivity. But science is saying something different. It's saying that the hours you spend sleeping may be the most biologically active hours of your life. That it is during the silence of the night that the brain performs work that no technology has yet been able to replace. Dr. Nedergaard once said that the brain has enough energy to do two things. But not both at the same time. Either it is conscious and active. Or it is cleaning itself. That trade-off is fundamental. And it happens every night, automatically, without you needing to do anything, as long as you allow it. As long as you sleep. The brain's night shift began millions of years ago, long before clocks, alarms, or glowing screens in the middle of the night existed. It is one of the oldest and most sophisticated systems in human biology. And perhaps one of the most important questions you can ask about your own health is not what you eat, or how much you exercise, but what happens inside your brain during the hours when you close your eyes. Because the answer may say a great deal about who you will be, decades from now. Beyond the years.